Good afternoon, everyone. Welcome back. We are going to now talk about combinations. So last time we have talked about permutations and this time we are talking about combinations. Yes, good afternoon, Nitali. Good afternoon, Sanjay. Yes, thank you so much. So remember, when we talked about permutations, we talked about factorials. So I'm just going to refresh your memory. 3 factorial is 6. How it has come to 6? 6 because we know that 3 factorial can be written as 3 into 2. Okay. 4 factorial is 24. 5 factorial is 120. So 5 factorial will be written as 5 into 4 into 3 into 2 into 1. Okay. And so on and so forth. Okay. Then we talked about the multiplication rule and the addition rule. What does the multiplication rule says that when you have a first thing and you can do it in m ways, and when that is done, the second one is done in n ways, then the total number of ways in which both of these things can be done is m into n ways. Okay. So that is the multiplication rule. What does the addition rule says? Say that when one thing is done in m way and an alternate thing can be done in n ways, then the total number of ways with which either of the jobs can be done is m plus n ways. Okay. So we talked about the example of a child going to school. So we say that if he's going to school by the bus, while going he has say maybe 5 routes with which he can go reach the school, and while coming back he has 4 ways. So 5 into 4, that is 20 ways in which he can go to the school and come back. Okay. But in the example, if I'm talking about how he can reach the school, so either he can go by bus or he can go by an auto. And then in that case, what will happen is that 5 plus 4, 9 ways. Okay. Remember that example that he has 5 buses with which he can go, or 4 autos, then he can go by 5 plus 4. Okay, so in this way he can reach the school in 5 plus 4, that is 9 ways. Whenever we have the word and, it implies that we are going to multiply, and whenever the word or is there, we are going to use addition. Okay. Now what is combination? Combination says, let us see the definition, the number of ways in which smaller or equal, that is R, that is R or N, that is R is equal to N, things are arranged or selected from a collection of things where the order is not important. So where the order is not important, it is called as combination. So number of ways in which smaller or equal number of things are arranged or selected from a collection of things. What is a collection of things? The number is n. We are selecting some which is r. R may be smaller than n or equal to n. So that if I have 5 students, I can select all 5. So that time r will be equal to n. But suppose out of 5 students, I am selecting only 3 students. That time R is less than N. Okay. So that, and when the order or selection is not, order of the selection is not important, it is called as combination. Now what is the formula? Remember the formula for permutation? What is the formula for permutation? Say N P R is equal to N factorial upon n minus r factorial. Now what does the formula for combination say? N C R is equal to n factorial upon r factorial into n minus r factorial. Okay. Now can you see? Just let me change the color. This looks similar. Okay. What does n factorial upon n minus r factorial represent? NPR. So we say that NCR is equal to NPR upon r factorial. Okay. This is also a very important formula. Or you can also write this as NPR is equal to R factorial into NCR. Okay. So, hope you've understood till now that we have talked about the multiplication rule, we have talked about the addition rule, and we have talked about what is combination. What is the difference between permutation and combination? In combination, the order of the arrangement is not important. And what is the link between permutation and combination? We say that NPR is equal to R factorial into NCR. And these are some of the very important formulas that we are going to use. Yes, Ishan, Sonali, Manjunath, Lakshita, Jia, Vishnu, Chaitanya, Malay, Zeba, Harshita. Yes, thank you so much. Yes, Harshita, we told you 30 to 50% marks are there for the 4 chapters. Okay. Yes, Manvi, we'll first finish the combination and then I'll take that sum. Okay, so very important is so that when you see this NC0, this is equal to 1. NCN is also equal to 1. NCN minus R, what this means is NCN minus R is equal to NCR. This is also very useful when solving sums, when you want to find N or when you want to find R. This means that if I have 5C3, this will be equal to 5C2. Okay. Because 5 minus 3 is 2. So this is 2. What about 7C5? Then this is equal to 7C5 minus 2, which is 7 minus. Okay, this is equal to 7 minus 5, 7 minus 5. N minus R. N is 7, R is 5. So this becomes 7C2. Now let us check this. Let us check whether this is true or not. Let us see. 7C5. Let us see the LHS. Okay, 7C5 is how much? 7 factorial upon 5 factorial into 7 minus 5 factorial. Okay, NCR, we know the formula. NCR is equal to N factorial upon R factorial into N minus R factorial, which is equal to 7 factorial upon 5 factorial into 2 factorial. How much is 7 factorial? 5040. How much is 5 factorial? 120. And how much is this? 2. 2 factorial is 2. So let us see what is the value. 5040 divided by 120 is equal to this divided by 2. Answer is 21. Okay. Now let us see how much is 7C2. Okay. 7C2 is 7 factorial upon 2 factorial into 7 minus 2 factorial. This is equal to 7 factorial upon 2 factorial into 5 factorial, which is equal to 5040 upon 2 into 120. So 5040 divided by 2 divided by 120 is equal to 21. Right? Here also we got 21. Here also we got 21. So from this you know that NCR is equal to NCN minus R. Okay. So this is an important, right? Understood? So this is a very important formula. The next important formula is this. N plus 1 Cn is equal to NCR plus NCR minus 1. This means, for example, if I have 5C3 plus 5C2, this will be equal to 6C NCR. think this is R. This is N plus 1C R is equal to NCR plus NCR minus 1. So this will be equal to 6C3. Okay. So this is equal to 6C3. Now let us go to the sum. First sum is on page 5.15, example number 2. Let S be the collection of 8 points in a plane with no 3 points on a straight line. Okay. Find the number of triangles that have points of S as vertices. So I have a plane and I have 8 points on it. So so this is a plane. I have 8 points and I want to, with no 3 points on a straight line, find the number of triangles. So I want to make triangles with this. So what will this be? So how much is N? How many points do I have? 8. How many points do I require? Points required to make a triangle is equal to 3, right? Because if I have this triangle A, or let me say it this way. Suppose I have points A, I have point B, and I have point C. Okay. Suppose I have that, then can I make a triangle? Yes. So I can make a triangle like this. So to make a triangle, how many points do I need? 1, 2, and 3. Okay. So we are saying here is that N is equal to 8 because this is given. And when they are saying triangles, I know that to form a triangle, I need 3 points. So we have number of triangles will be equal to 8C3. How much is 8C3? This is equal to, what is my formula? NCR is equal to N factorial upon R factorial into N minus R factorial. This is equal to 8 factorial upon 3 factorial and 8 minus 3 factorial. Here my N is equal to 8, R is equal to 3. So 8 factorial upon 3 factorial into 5 factorial. Now I always remember that 7 factorial is 5040. Okay. So this I can do is equal to 8 into 5040. How much is 3 factorial? 6. How much is 5 factorial? 120. So this is equal to 8 into 5040 divided by 120 divided by 6. Answer is 56. Answer is 56. So you can form 56 triangles when using 8 points in a given plane. Now, this is one way of doing it. The second way, if you don't remember that 7 factorial is equal to 5040, don't worry. 8 factorial, we will write up to 5 factorial. So 8 into 7 into 6 into 5 factorial upon 3 factorial, at least you know 3 into 2 is 6 into 5 factorial. Okay. Now, this 5 factorial will cancel with this 5 factorial. And what will I get? And okay. And then this 6 will also cancel with this 6. So what am I left with? This is equal to 8 into 7, which is equal to 56. Understood? Yes, understood till now? Yes, Bihu. Excellent. Yes, Rahul. Good, good. Yes, actually, you have to understand. While you read the sum, you will be able to know whether it's a permutation or a combination sum. So for that, you will keep reading sums, solving them. So you will realize the main thing is where the order is important. Where they're saying that no two brothers can sit next to each other, or no two sisters sit, or sisters sit together, or vowels are there together. All these are indication that that's a permutation sum. Okay. And that is why it's more of understanding that you have to understand first and then try to do it. Now, a committee is to be formed of 3 persons out of 12. Find the number of ways of forming this committee. Okay. See, again, you can select any person anytime. There is no first prize, second prize, third prize, right? This is a question in which I have 12 people and I have to select 3 people to form a committee. So this is a combination sum. So n is equal to how much? 12. R is equal to how much? 3. So I have number of ways of forming committee is equal to 12C3, which is equal to 12 factorial upon 3 factorial into 12 minus 3, that is 9 factorial. So this is equal to 12 into 11 into 10 into 9 factorial upon 3 factorial I know is 6 into 9 factorial. So 9 factorial will get cancelled. 6 ones are 6 twos are. So what will I get? I get this as 220. Okay. Answer is 220. So there are 220 ways in which I can form the committee. Clear? Next sum. Okay. A committee of 7 members is to be chosen from 6 chartered accountants, 4 economists, and 5 cost accountants. In how many ways can this be done if in the committee there must be at least one member from each group? Okay, so important line is at least one member. At least one member from each group and at least 3 CAs. Okay. So what is the condition here? That we must have at least 3 CAs and at least one economist and at least one cost accountant. Okay, how many members are required? N is how much? So N1 is 6 because there are 6 CAs. Okay. Then I have N2 is how much? 4. That is economics. N3 is how much? 5, which is equal to ICWA. And what is the condition? 3 chartered accountants. And what is R? R is equal to 7. So what will I have? What are the possibilities? Let us see. Okay. Okay, this is CA, this is economist, and this is ICWA. Okay. Now all this total should come to 7. What is the first possibility? That I take 3 because at least 3 CA, so I take 3 and then if I take 3, what can I have? I can have 4 economists. No, because I should have at least 1 ICW and 1 at least economist. So because I need 7 minus 3. 3 already I have CS, so remaining how much? 4. So out of that, I can take 3 economists and 1 ICW. I can take 3 CAs, I can take 2 economists and 2 ICW. I can take 3 CAs and I can have 1 economist and 3 ICW. Okay. Then what can I have? At least 3. So I can have how many? How many CAs do I have? 6. So I can have 4, 5 and 6. So for each of this, I can have this combination, right? So what will I have here is, when I have 4 CAs, how many economics suppose I have? I can't have 3 over here because 4 plus 3 will be 7. So I can have 2 economists, and how much can I have here? I can have 1. So 4 plus 2, 6 and 1, 7. If I have 5 CAs, what can I have? I can have 1 economist and 1 ICW. If I have 6, can I have the 6? No, I can't, because then the total is 7, so I can't have that. So I will have to rub this up. What is remaining here is, for 4 CAs, what can I have? I can have 2 economics and 1 ICW, or I can have 1 economist and 2 ICW. Okay, I can have 1 economist and 2 ICW. Is there any other possibility? No, because I need at least 1. So I can have this condition where I have 3 CAs. So this is 3, 1, 1, 3 and 2, 2. If I have 4 CAs, so I have 4, 2, 1 or 4, 1, 2. If I have 5 CAs, 5, 1, 1. Okay. I cannot have 6 CA, even though I have 6 CAs available with me, I can take all of them, because the committee size is 7. I will need 1 economist and 1 ICW. Yes. So let us see how much is this. This is, how many CAs are there? 6. So 6 C3 into, how many economists? 4 C3 into, how many? 5 C1. Okay. Then here it will be 6 C3 into 4 C2 into 5 C2. Here it will be 6 C3, 4 C1, 5 C3. Then I have 6 C4, 4 C2 and 5 C1. 6 C5, 4 C1, 5 C1. Here it will be 6 C4, 4 C1 and 5 C2. Okay. If I solve all of this, this is going to give me 3, 5, 7, 0. Okay. So what we have done here is that I have been given a group of CAs, economists and cost accountant, and I have the condition that this group should contain at least 3 A's, and that this group should contain at least 1 ICW and 1 economist. And for that, we have tried to see what are the possibilities. The possibilities are that I have 3 CAs, at least 3 CA means 3 CA, 2 economists, 1 ICW. 3 CAs, 1 economist, 2 ICW. 3 CAs, 2 economists, 2 ICW. That is the part with 3. What about 4? 4 I can have, when I have 4 CAs, then I can have 1 economist and 2 cost accountant. I have 4 CAs, 1 cost accountant and 2 economists. And the last is when I have 5 CAs, I will have 1 each of cost accountant as well as economist. Okay. You just have to try to understand this. Yes, Kirti, yes. Like Kirti, once you come to know, Ronit, you have to solve all this. For example, I will just show it for you for one, because if I do this arithmetic, we will not be able to solve many sums. So 63. How much is 63? I'll just show it over here. Let me just show you this. 6C3, 4C3, and 5C1. Okay, how much will this be? 6 factorial upon 3 factorial into 3 factorial into 4 factorial upon 3 factorial into 1 factorial into 5 factorial upon 1 factorial into 4 factorial. Now this I know is 720 upon 6 into 6. 4 factorial is 24 upon 6 into 5 factorial is 120 upon 24. So this 24 gets cancelled. I will get 720 into 120 divided by 36 divided by 6. So I get this as 400. Okay. So similarly, when I solve for all of them and I add all of them, I will get 3570. Okay. So you just have to put the formula, find the answer, and when you find the answers, you will have to total them. So after you found the answers for each of these, okay, so this is one group, then this is another group, this is the third group, and so on so forth, you will add them up and you will get 3570. Okay. Yes, Kunal, you solve like this. Example 4, see, you have to use both multiplication rule and addition rule. Multiplication rule says what? You do one thing, and once that is over, you do another thing, and when that all the things are done, you say m into n. Okay, so here what was the first thing? We selected a committee, so we use the multiplication rule. But what does the addition rule say is that if there is an alternate method of doing things, what will be the total ways in which either of the methods is used? So you can have a committee either see once I've made a selection, so this will be first selection, this will be second selection, this will be third selection, fourth selection, fifth selection, and sixth selection. So there are 6 ways to form the committee, but I will select only one of them, right? So how do I select? So this is multiplication and then I add them. Okay. Once you do more and more sums, you will get the importance and you will know whether to apply the multiplication and when to apply the addition. Now, a person has 12 friends, of whom 8 are relatives. In how many ways can he invite 7 guests such that 5 of them are relatives? So, what will happen over here? Just a minute, let me put on the power button. Just give me a moment. Okay. So we have 4 people. We have to find out how many ways in which he can invite guests such that 5 people, 5 of them are relatives. Okay. So how many friends? 12. So n is equal to 12. How many relatives? 8. So, and how much of them? He has to invite 7 people. Out of 7, he has to invite 5 who are relatives and 5 are relatives and 2 are non-relatives. So, when I have 12 people, of them 8 are relatives. So, how many will be non-relatives? This will be 4. Okay, 8, then 4. So, we have to select out of these 8 relatives. How many do I have? 5 of them have to be relatives. And out of the remaining non-relatives, how many non-relatives are there? 4. Out of them, how many have to choose? 2 should be chosen, which is non-relative. So 2. So how much is this? 8 factorial upon 5 factorial into 3 factorial. How did I get 3? 8 minus 5, 3. Into 4 factorial upon 2 factorial into 2 factorial. So this is how much? 8 into 5040 upon 120 into 6 into 24 upon 4. So let us see. Eight into 5040 is 40320 and divided by 720 is 56 divided by 4 into 24. 336. Okay. This is equal to 336. Right. So what I have? 12 people. Out of these 12 people, 8 are my relatives. Out of these 8 relatives, I have to select 5. Okay. 12 people, 8 are relatives, 4 are non-relatives. Out of 8, how many do I need? 5. Out of them, how many will there be there? 7 minus 5, because total people he wants to invite for the party are only 7. So 7 minus 5, so 2. Okay. So that is why this 5, it's come from here. Right. This 5. So we have out of 12 people, 8 people are relatives, 8 C5. Non-relatives are 4. How many out of 4 I have to invite? 2. So 4C. Okay. Next sum is this. Is it clear? You have to just write down first what they have written. Okay. Yes, Rahul, I have repeated. Any other you want? Yes, very good, Sanjay. Barkat, we are taking more sums, don't worry. Yes, good, 336. Now let us go to the question 5. On page 5.17, that is the 8th example. Okay. Now here what happens is, in each case find n. So we have 4 into nc2 is equal to n plus 2c3. Okay. Always remember this, that I can write n plus 1 factorial to be equal to n plus 1 into n factorial. Or I can even take it further depending on what I require. This is n plus 1 into n minus 1 factorial. So I can go down, and subtract 1, 1, and I can do that. So let us first consider this example. 4 into nc2 is equal to n plus 2c3. Okay. So what will happen over here is, I have yes, Rahul, good. You got that. This is simple, beta. There is nothing to worry about, So this is 4 into n factorial upon 2 factorial into n minus 2 factorial. Okay, 4 into n factorial into 2 into n minus 2 factorial. What will come over here? N plus 2 factorial upon 3 factorial into n plus 2 minus 3 factorial. Okay. Now this will be, now I will write n factorial up to n minus 2 factorial. So this is 4 into n minus 1 upon 2 factorial, I know is 2 into n minus 2 factorial. This thing upon n minus 2 factorial. Okay. So on the left hand side, let me simplify this. On the left hand side, I will have 2 ones are 2 twos are. And here n plus 2 factorial and n minus 2 factorial, n minus 2 factorial will get cancelled. Let us see on the right hand side what will happen. This is equal to n plus 2 factorial, and what will happen in the denominator? This is n plus 2 minus 3, so it will be equal to n minus 3. Okay, n minus 1. N plus 2 minus 3 will be equal plus 2 minus 3 minus 1, so this will be n minus 1. So I will write n plus 2 factorial up to n minus 1. So I will write this as n plus 2 into n plus 1 into n minus 1 factorial. Upon, how much is 3 factorial? 6, and into n minus 1 factorial. This n plus 2 minus 3 becomes n minus 1 factorial. So I will have this n minus 1 factorial. This n minus 1 factorial will cancel with this n minus 1 factorial. So what will I be left with? On the LHS, what do I have? 2 into n minus 1. Okay, on the LHS, I have 2 into n minus 1 is equal to n plus 2 into n plus 1 into n upon 6. Okay, upon 6. So what will happen? This n will cancel with this n. Okay, so I have 12. I have 12 is equal to n plus 2 into n plus 1 up, into n plus 1 upon n minus 1. Okay. So I have this. So when I simplify this, what will I get? I will get n's value to be equal to 2 or 7. Okay. I will just show you how we will be doing this. Okay. Let me just add a page here because I am not able to show it here. Let me see. Okay. There is no place here. Okay. Okay. I'll just put some place over here so that you'll be able to see the remainder. Okay, let me take this sum last because it will require a lot of place. So I have place in the end. So I will take it over there. Okay, let us do the other sum. So that last one, I'll just show these two sums because they require a little more space. Okay, don't worry, we will be doing those sums. 10PR. Okay, next sum is 10PR is equal to this. What is the relationship between permutations and combination? I know that NCR is equal to NPR is equal to R factorial into NCR is equal to R factorial into NCR. Now let us see this here. I have N is given to me as 10. Okay, N here gives me N. Now I need to find the value of R. So 10 PR is equal to R factorial into 10 CR. But 10 CR is already given to me as 120. And this value I know is 604,800 is equal to R factorial into 120. This means that R factorial is equal to 604,800 upon 120. Now, what is the value of 604,800? 604,800 divided by 120 is equal to 5040. R factorial is 5040. Now let us go back to the chart that we have made for ourselves. How much is 5040? It is equal to 7 factorial. Okay, 5040 is equal to 7 factorial. So we have the sum 5040 is equal to 7 factorial. That means R factorial is equal to 7 factorial. So R is equal to 7. Okay. Is that clear? Yes, Zeba. Kirti, Aman. Yes, Nital. Yes, Tejashri, when you have options, there is no problem. You can just option, suppose in the option they have given you 7. They will give you 7. Then you find 10C7. If it is coming to 120, yes, you can do that. That is also there. Okay. Yes. Yes, Anju, very good. Okay, the next sum. Let us find R if 18CR is equal to 18CR plus 2. Now here what happens is that we are using this very important property NCR is equal to NC n minus R. Okay, so I can write 18CR to be equal to 18C 18 minus R. Okay, so 18CR is equal to 18C 18 minus R, which is equal to 18CR plus 2. So we have 18 minus R. Okay. We are equating this 18CR 18 minus R to be equal to R plus 2. 18 minus R is equal to R plus 2. So I have 18 minus 2 because I take the plus 2 onto this side, it becomes minus 2, and I take the minus R here. So it will become 2R. So I have 2R to be equal to 16. R is equal to 8. Is that clear? Now you may say, कि ma'am, यहीं पे क्यों नहीं equate किया? Why didn't I equate R and R plus 2? So here what is happening is, if I say R is equal to R plus 2, R will get cancelled on both sides and 0 is equal to 2. Do we have this system? No. We can't do that over here because a combination is unique. So in combination, this I have to use. I have to use this property to be able to find it. So NCR is equal to NC n minus R. So after that I have equated and I have found the value of R as equal to 8. Is that clear? Next, a box contains 7 red, 6 white and 4 blue balls. So I have 7 red plus 6 white plus 4 blue. How much is this equal to? 17 balls. Okay. How many selections of 3 balls can be made so that all 3 are red? How many red balls do I have? 7. So 7C3. Okay. For all balls to be red, 7C3 is 7 factorial upon 3 factorial into 4 factorial. 7 minus 3 is 4. This is equal to 5040 upon 3 factorial is 6 into 4 factorial is 24. So how much is this? 5040 divided by 6 divided by 24. Answer is 35. So in 35 selections, we will get all 3 balls as red. Now, what is the second? None is red. None is red means I will not consider the 7 red. How many remaining balls are there? 6 white and 10 black balls. So 6 white and 10 black balls means 10C3. None is red. So this is equal to 10 factorial upon 3 factorial, and 10 minus 3 is 7 factorial. So this is 10 into 9 into 8 into 7 factorial upon 6. 3 factorial is 6 into 7 factorial. So I am going to cancel the 7 factorial. This becomes how much? 720 upon 6, so which is equal to 120. Correct? Yes. So in 120 selections are there where there is no red ball. Okay. In this case, all 3 balls are red. All 3 balls are red. Third option is what? Third subpart of the question is what? One of each color. One of each color. So out of 7, one of each color is equal to 7C1, 1 red, 6. One of each color is equal to 1 of red, 7C1. How many white balls are there? 6. So 6C1 will give me 1 white ball. And how many blue balls are there? 4. 4C1 will give me 1 blue ball. So 7C1 is 7. Okay. Because this is 7 factorial upon 1 factorial into 6 factorial. So this is 7 into 6 into 4. So this is 24 into 7. 24 into 168. Let me check. Yes. So this is 168. Is that clear? So in this sum, we have taken 7 red, 6 white and 4 blue balls. So in that each color ball will be there. Yes, Vishnu, which sum? This sum you want me to repeat? Just let me know which sum you want me to repeat. Okay. Kirti, it's not 166, it is 168, right? Vishnu, let me know. Now next sum is okay. Next sum is 28C2R is to 24C2R minus 4 is equal to 225 is to 11. Okay. So we have to find the value of R. Okay, Pradnya, I will see. I will let you know. Now I have how much? This is 28 factorial upon 2R factorial into 28 minus 2R factorial on the left hand side upon. So this upon 24 factorial upon 2R minus 4 factorial into 24 minus 2R plus 4 factorial. Okay. So this sign is to, so that means 1 upon the other. So I have a fraction in the denominator. I will flip it. So what will I get? This will equal to 28 factorial upon 2R factorial upon 28 minus 2R factorial into, this will become 2R minus 4 factorial into 28, because this 24 and this 4 becomes 28. 28 minus 2R factorial upon 24 factorial. Okay. Please pay attention now. What I will do, I will write this 28 up to 24. So this will become 28 into 27 into 26 into 25 into 24 factorial. Okay. Now, in the denominator, can you see 28 minus 2r factorial? In the numerator also there is 28 minus 2r. This will cancel with this. Okay. And from 2r factorial, I am going to write up to 2r minus 4. Okay. So, this I will write from 2r up to 2r minus 4. So, it will be 2r into 2r minus 1 into 2r minus 2 into 2r minus 3 into 2r minus 4 factorial. Right? I am writing this 2r up to 2r minus 4. Right? Into, this is 2r minus 4 factorial upon 24 factorial. Okay, this 2r minus 4 and upon 24 factorial I am writing as it is. So I will find that this 24 factorial I can cancel with this, and this 2r minus 4 factorial I can cancel with this. So what I get here is this is equal to, what is this equal to? 225 upon 11 is equal to 28 into 27 into 26 into 25 upon this whole thing, 2r into 2r minus 1 into 2r minus 2 into 2r minus 3. Okay. Now let us see how much is this equal to 225 . This is 15 into 15. Okay. And this is equal to how much? 11 into. Okay. So I have 28 into 25. So I can cancel this as 28 into 27 into 26 into 25 is equal to 49140 into 11 equal to this divided by 225 equal to this. So I cross multiply and I get 2r into 2r minus 1 into 2r minus 2 into 2r minus 3 to be equal to 24024. Okay. Now you will have options over there. So you will put in the option, and whichever option when you put over there, you are getting as 24024, you will take that R value as the correct value. Okay. So you will have to substitute and see. Now let me just check. Okay. Let us see. 24024. When I divide this by 8, do I get? I get 3003. Okay. 3003 divided by 3, I get 1001. Divided by 11, I get 91. Okay. So I can write 24024 to be equal to 8 into, so 24024 divided by 8, I'm getting as into 3003, which I can write as 8 into So this divided by 11, I'm getting as into 11 into 273, which I'm getting as 273 divided by 13 divided by 12. 273 divided by 13, I'm getting as 21. So 8 into 11 into 21 into 13. 13 into 11. Yes. So now I have this 21. So 21 can be written as, I'll just see where I can write this. So this is equal to 8 into 11 into 21 into 7 into 3 into 13. Okay. But see what I want, 2r, 2r minus 1, 2r minus 2, 2r minus 3. So I must have these numbers in the descending order. So, and they must be consecutive numbers. So here I can see 13. So let me see. And here I have 7. So I will write this as 14 into 13 into 12 into 11. Okay. So let me check. 14 into 13 into 12 into 11. I get 24024. So that this is equal to this. So how much is my R? 2R is equal to 14 and R is equal to 7. Okay. So in this case, because I did not have the option, I have to do it manually. But you don't have to worry. In the exam, you will come up to this place. Okay. If you come up to this place, you just have to substitute the 4 options and you will get the answer. And even here, when you have R, so you will just put in any values of R that are given in the option, you will be able to find the answer. But I must tell you the method, and I have told you the method. You can come up till here. You don't even have to do all this. You will just put in the options that are available with you. Okay, so don't worry about this. This is for your understanding. Now, if I have this, okay. Now I know that n plus 1 CR, this is R. Is equal to NCR plus NCR minus 1. Okay. So you have to find the value of x. So this is given to you as 14cx. Let us see. Now I know this. This is left hand side. So I will show you. I have 12c5 plus 2 times 12c4 plus 12c3. Now I have 2 times 12c4. So I'm going to write this as, this is 12c5 plus 12c4. Okay, this 2 times I'm writing as 12c4 plus 12c4 plus 12c3. Okay, this I'm writing as here. Okay, I've just written 2 times 12c4 as this. So this over here, this and this I'm combining, and this I'm combining. Okay, I'm combining this. So what does the formula say? That NCR plus NCR minus 1. So here how much is R? 5. So 5 and this becomes 4. 5 minus 1, 4. And N are the same. So this for this, it can write this as 12 plus 1 C5. Okay, 12 plus 1 C5. Plus, what will happen here? What is R? R is 4 here. 4 and 3. 4 and 4 minus 1, 3. So this will become plus 12 plus 1. 12 plus 1 C4. So how much is this? 13 C5 plus 13C4. Can't I apply the method again? R minus 1. 5 minus 1. Okay, so this will become 13 plus 1 C5, which is equal to 14C5. Okay, which is equal to 14C5. Now you know, if I stop over here, what they're asking me to find out, this is equal to 14CX, which is given in the sum, 14CX. So here it looks like that X is equal to 5. Okay, 5 is equal to X. But also remember the important property. What is the important property? That NCR is equal to NCN minus R. Okay, this is a very important property. So using this over here, I have 14C5. 14C5 is equal to 14C. 14 minus 5 is 9. Now this will also be equal to 14CX. Therefore, X is equal to 5 or 9. Very important sum, because I have to know that I will get two values. Okay, so this is important. Okay, so this is important. So I'm getting 5 or 9. Just let me check the answer. 14 sum. So this is the correct answer. Okay, understood till here? Yes, Kirti. X is 5. Right? Yes. Okay. So important here, you have to remember are the two formula. N plus 1 CR is equal to NCR plus NCR minus 1. And NCR is equal to NCN minus R. These two we are applying over here. Okay. So I'm taking all the difficult sums so that you are able to understand simple NCR sums you can do on your own also. We have taken 4 or 5 sums earlier also. And now these are the important sums where you must know. Over here, see, the most important step is here. So here, okay. Remember, in this sum, you have to remember first point what? Write 12, 2 times 12C4. You have to write this as 12C4 plus 12C4. Okay, that is the first step. First important thing you have to remember. Second important thing is using NCR to be equal to NCN minus R. Okay, these two things are very important. Now these, there are few questions that you may get in theory also, and you may have sums also. So they will give you this wordings, and then they will give you formula in the 4 options, and you have to select the correct formula. So what are the important things that you need to know? Okay, Nital, here what you have to remember is this. You want me to explain again? Let me do that. Here you have to remember these two formulas. So first important step, I'm not rubbing the important things, so you can copy from there also. In this sum, there are two important things. First is expansion of the given equation. Second thing is using two formula. Okay. Okay, remember you have to write 12C4 as 12C4 plus 12C4. And second important thing is writing NCR is equal to NCN minus R. Okay. Now let me show you again. So what is the sum? The sum is saying 12C5 plus 2 times 12C4 to be equal plus 12C3 to be equal to 14CX. Right? Now, I will write this. I will expand this. So, I will write this as 12C5 plus 12C4 plus 12C4 plus 12C3. Okay. Now, here I'm going to club this, and here I'm going to club these. When I club these, I'm going to use the formula NCR plus NCR minus 1 is equal to N plus 1CR. So this will become 12 plus 1C. What is the value of R in these two? R is 5 because one is R, another is R minus 1. So this is in this plus. Now 12C4 plus 12C3. How much is N? N is 12. How much is R? R is 4 because this is R minus 1. So this will become 12 plus 1C4. So how much is this? This becomes 13C5 plus 13C4. Again, I can use this formula NCR plus NCN R minus 1. So this is 5, this is 4. How much is N? N is 13. How much is R? R is 5 because this is 5, this is R is 5 and this is R minus 1. So I will have this to be equal to N plus 1. So this will be equal to 14C5. Okay. Now I have 14C5. This is what I get after solving all this. And what is on the RHS? RHS says this is equal to 14CX. So I have X to be equal to 5. Okay, that is one option. But because I know that NCR is equal to NCN minus R, what I do is I have got this as 14C5 will be equal to 14C9 because 14 minus 5 is 9 will be equal to 14CX. So this is equal to X can take the values 5 and 9. So X can take the values 5 and 9. Clear? Hope it's clear now. Nitar? Barkhat, we are not writing NCR. I am writing NCN minus R is equal to NCR. I am not writing NCR is equal to NCR. I am writing NCN minus R is equal to NCR. So that when I have 14C5, that is also equal to 14C9. Where did this 9 come from? That is 14 minus 5 is 9. Okay. Zeba, I will take it in the revision class. Question number 13 because it's lengthy. It is only calculations, but I will take it. But I will hold a revision class. In that class, I will take it for you. Okay, don't worry. Yes, see, Lisa, that when options are given, they will give you 5 and 9 and only 9. So you must select 5 and 9. Why? Because 5 is also correct. Then there is no doubt about it. But 5 and 9 will be the better answer because both these are satisfying that equation. Okay. So now when n1 are number of exactly alike things, when n2 are number of exactly alike things, and when n3 are number of exactly alike things, and the rest of the n things are different, then the number of ways in which n things may be arranged are given by p is equal to n factorial upon n1 factorial, n2 factorial, n3 factorial. Okay. Like in case of balls, you have many balls. So of them, like you will have 7 red, 7 white, 7 reds, 5 white, 4 blue. So those are N1, N2, N3. Or you may even have vowels and consonants. So you may have A vowel, I vowel, and the others are consonants. So all these type of sums can be solved in this way, which says that n things may be arranged and given by p is equal to n factorial upon n1 factorial, n2 factorial, n3 factorial, and so on. How many different permutations are possible for the letters of the word calculus? Okay, important thing here is any word problem, you have to think, check repetitive, letters. Okay. Now, the word calculus. C-A-L-C-U-L-U-S. Now, what happens? I can write this as C-A-L-L-U and S. 1, 2, 3, 4, 5, 6, 7, 8. 2, 4, 6, and 8. Okay. So these are the different permutations and combinations for this. So calculus, you have P is equal to 1, 2, 3, 4, 5, 6, 7, 8. This is equal to 8 factorial upon 2 factorial into 1 factorial into 2 factorial into 2 factorial. This is 2 factorial, 1, 2 factorial, 2 factorial, and 1 factorial. So this is equal to how much? 8 factorial upon. So I think they will not ask you to expand this. You will be giving the answers like this. So here we have used this. P is equal to n factorial upon n1 factorial, n2 factorial, n3 factorial. So similarly, we have written P is equal to 8 factorial upon 2 factorial into 1 factorial, 2 factorial. Where is this 2 coming from? This 2 is for C. The next 2 is for L. The next 2 is for U. So this will be the answer. When each of the n things may be repeated once, twice, up to r times, then the number of ways of arranging these n things taken r at a time, each thing being repeated r times, is given by n raised to r. Okay. So this theory you should know. When each of the things may be dealt with in either of the two ways, that is, it may be taken or left, then the total number of ways in dealing with n things will be given by 2 raised to n minus 1. What does this mean is that suppose I have option in the exam. I may be asked that you out of 10 questions attempt 5 or say maybe attempt 6. So what happens for each question? Question number 1, I will think, should I attempt or should I not attempt? Question number 2, I will again do attempt or non-attempt. So all this is given by, that is, I have 2 options, okay, attempt or non-attempt. So that is why this 2 comes from there, that I have an option, that is take it or leave it. So either I will take the question and try to solve it, or I will leave it, or I will skip, because out of 10 I have to do only 6. But I am also having -1, so that we don't take the condition that I am not going to answer any questions. So that I'm not appearing for the exam. We remove that. So you have 2 raised to n minus 1. Okay, I just told you the logic behind it. You don't have to worry. In the exam, they will just give you this. You have to tick mark 2 raised to n minus 1. Why that 2 raised to n is because either I can take a subject or leave it. I may say yes or I may say no. So because of that, we have 2 raised to n. And why the -1? Because we do not take the condition that the child is not going to sit for the exam. Okay, we don't take that situation. So this is 2 raised to n minus 1. So let us take an example with that. An exam paper with 10 questions consists of 6 questions in algebra and 4 questions in geometry. At least 1 question is to be attempted. In how many ways can this be done? Okay. So paper selection of algebra will be equal to 6, 2 raised to 6 minus 1, because I can't say that I'm not going to attempt algebra. Why? Because at least 1 question from each section is there. At least 1 question from each section. So this is 2 raised to n. So paper selection for geometry is equal to 2 raised to 4 minus 1. So answer is equal to 2 raised to 6 minus 1 into 2 raised to 4 minus 1 will be the answer. And if they want you to expand, then you can write 2 raised to 6. How much is 2 raised to 6? 2 into 2. Okay. So 2 into 2 into 2 into 2 into 2 into 2. So 64 minus 1. Okay. So this will be 63. And 2 raised to 4 will be 2, 4, 8, 16. So 16 minus 1, 15. And then you will have to multiply. So this is the way you have to do this. Now the next formula that we have to take care of is this one. When out of n things, n1 numbers are exactly alike and n2 numbers are exactly alike, then such that n is equal to n1 plus n2 plus n3 up so on, then the number of ways in which groups can be formed by taking sum of all out of n things is given by n1 plus 1 into n2 plus 1 into n3 plus 1 etc. minus 1. Okay. So then I have n1 alike things, n2 alike things and n3 alike things, and then I have to do that. So this will be the answer. n1 plus 1 into n2 plus 1 into n3 plus 1 so on minus 1. The combination of selecting R1 things from a set having N1 objects and R2 things from a set of having N2 objects where the combination of R1 things and R2 things are independent is given by N1C R1 into N2C R2. This we've already used in the balls question. Okay, here we have taken. Okay. NC1 into NC 7C1 into 6C1 into 4C1. Here we have already used this formula that there. So I'm just telling you that sometimes you will get these questions for theory, so I've put them together in one place. Now there are 7 men and 3 ladies. Find the number of ways in which a committee of 6 can be formed of them if the committee is to include at least 2 ladies. Okay. So at least 2 ladies means what? How many ladies are there? 3. So I can have 2 ladies or 3 ladies. Okay. See, I'm using the word or. So first I will find for 2 ladies. Then I will find for 3 ladies and I will add them because I've used the word or. Okay. You remember the multiplication and addition rule? Okay. So 2 ladies mean 2 ladies plus 4 gents. Then I will have 2 ladies. I will have 3 ladies plus 3 gents. Can I go further? No, because 3 ladies are the maximum ladies present here. So for 2 ladies, I have to select from how many ladies? 3 ladies. So this is 3C2 into 4 men. I have to select from 7 men. So this is 7C4. How much is this? 3 ladies is 3C3 and 3 gents is equal to 7C. Now, how much is 3C2? 3. And how much is 7C4? 7C4 will be 7 factorial divided by 4 factorial, that is 24, divided by 3 factorial, that is 6. So, answer is 35. Three C3 is 3 into 7C3 is, just now I found out 7C4 is equal to 35. So this will also be equal to 35. So this is equal to 105. So at least 2 ladies, this will be equal to 35 plus 105, which is equal to 140, which is equal to 1. Okay. Example number 5, we have 140. Find the number ways of selecting 4 letters from the word examination. Okay, from here I can see that A is repeated, I is repeated, N is repeated. So you have to be very careful. Let us check how many letters are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, so N is equal to 11. Now let us see. Is E repeated? No. Is X repeated? No. A repeated? Yes. This is A and A. Okay. Then M. M is repeated? No. Then I is repeated? Yes. I, 1 and 2. N is repeated? Yes. N, N. T is repeated? No. I is repeated? I already done that. And O is repeated? No. And N is not repeated. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. No. N I have already written. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I will write this here. AA, II, and NN. And what are the other alphabets who are appearing singly? This is E, X, M, T, O. Is that clear? So now what my options are? I have to find a way of selecting these. So first option is what? Two pairs of same alphabet. So how many pairs are there? 3 pairs. Out of 3, I am choosing 2. These 3 pairs are there. Out of these 3, I am choosing 2. Second option is that I have I take one pair and others from collection. So here how many pairs you have? 3 pairs. So 3C1. Okay. What will happen now? What are the remaining? Because here I have taken 1. I need 3 more letters. Okay. I will need 3 more letters. So how many are there? So what will happen in this case? Suppose I have chosen, let me show by an example, write it in example. Suppose here I have already chosen, this is just an example. Question 2, already chosen AA. Okay. Then what will happen is here I will have, I can take one of I, one of N, E, X, M, T, O. 1, 2, 3, 4, 5, 6, 7. Okay. So I have taken this and one of I, second of N, third X, E, then X, then M, then T and O. 1, 2, 3, 4, 5, 6, 7. Okay. Seven C. How many will I need? Yes, 7C, 3. Okay. And in the third, what will I have? Third option is I'm choosing all from different. So I will have A, I will have I will have N, E, X, M, T, O. 1, 2, 3, 4, 5, 6, 7, 8. So this is equal to 8C3. Once I do 8C4, sir. 4. When I do 8C4, what will the value be? 8C4 is equal to 8 factorial upon 4 factorial into 4 factorial. So this is equal to 8 into 7 into 5 into upon 24 into 24. Into 5 divided by 24. Okay, 8C4 is 8 factorial upon 4 factorial into 4 factorial. So this is giving me into 6. So this is given me 8 into 7 into 6 into 5, that is 1680 divided by 24 divided by 24. Okay. So this I will get the answer like this. 8 minus 4, 4 factorial and then 4 factorial because this is 4. And I have to select 4. So here, once I find these, so how much is this for first pair? First pair is 3 factorial upon 2 factorial, which is equal to 3, which is equal to 3. 3 is 7 factorial upon 4 factorial into 3 factorial, which I know is 35. And I have to solve this also. And I will get, how much did I get? Example 6. This is equal to 3C1 so I can cancel this. What will I get? 7 factorial 5040 divided by 24 divided by 105. Okay. Yes, I know it is tough. I know it is tough. That is why I'm taking these sums so that you are able to understand them very well. Okay, you can do the normal calculation yourself. Okay, don't worry. Most important is that you understand the concept. See here what has happened is in the word examination, which are the alphabets that are repeated? A is repeated 2 times. Okay, now pay attention. So you'll understand. Yeah. Who posted the question? Yes, I'm sure. Bala, yes. Okay. Yes, Ardhendu. Yeah. Now pay attention. How many alphabets are there? Okay, forget about the calculation part. Just understanding first. Let us see. You have the word examination. How many alphabets are there? 11. Out of them, some alphabets are repeated. Let us see. Which are the alphabets repeated? I can see that A is repeated 2 times. I is repeated 2 times, N is repeated 2 times. So this is 2 plus 2, 4, 4 plus 2, 6. And then remaining letters are not repeated. So E, X, M, T, O. So these are 5 letters and these are 6 letters. So I have how much? I have 11 letters. Okay. Now, first option is I select only from AA, I, I, and N. Okay, so what happens here is I can select any 2 amongst them. So what this will be, this is 3C2. Because out of these 3, I'm selecting any 2. So I can select AA, or I can select IINN, or I can select AANN. Okay, this is clear? Yes. Second point. Second may be that I select one from this, one from these. Okay, so out of 3 pairs, I choose one, and remaining two alphabets, I select from I, N, and then E, X, M, T, O. 1, 2, 3, 4, 5, 6, 7. Okay. Have you understood here? So how many do I select? From here, I select 2. Okay. Then I have the third option that I select all different. I select all different. So I will see A. Then I will select 1I, 1N, E, X, M, T, O. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so out of 8, I select 4. Now here what will happen? Here I have one pair I have already chosen. So one pair is gone. So I can have this situation when I've chosen AA, or I can choose II. So then it will be AA. So from A, N, E, X, M, T, O. Or it may be the condition that we have chosen N. So I will write A, I, E, X, M, T, O. Okay. This is the way you have to select the pairs. Select the 4 letters from the word examination. Okay. Ardhendu, Bala, I hope you have understood. Next sum is number of ways in which 12 students can be equally divided into 3 groups. So now what happens is I have 12 students. I have to divide them into 3 groups. So how many students in one group? So each group will contain 4 students, right? I have 12 students. So in each group, I will put 4 students. So what happens? First 12 students, I put them in one group. So 12C4. What will happen? One group is formed. Now, how many students remain? 8 students remain. And how many students do I want in that group? 4 students. So into 8C4. Again, second group is formed. What happens? How many students are left? 4 students. So 4C4. Okay. So let me solve this for you. So this is 12 factorial upon 4 factorial into 8 factorial into 8 factorial upon 4 factorial into 4 factorial into 4 factorial upon 4 factorial into 1 factorial. 0 factorial. Okay. Now here you can see that I can cancel this 8 factorial with this 8 factorial, 4 factorial with this 4 factorial. Now what will remain is 12 factorial upon this much. So let me see how much is that. Well, into 11 into by 24 divided by 24. So I have 34650. Okay, 34650. So you will have so many students. Okay, now what happens is, so what happened was I have to form 3 groups. Group number 1, group number 2, group number 3. In group number 1, when I started, I had 12 students. So I put 4 students here. Okay, 1, 2, 3, 4. Once I've put those 4 students, what will happen? For this group, I had 12 students and then I put in 4 students. For this group, I had 8 students and then I put 4 students in that group. Well, how many students will remain? 4 students, and all these 4 students will go here. Okay. So this is the way in which you will put students in the group. But very important. Okay. Now let me put this. Remember this, that here again, I don't know whether I selected the first group first, the second group first, or third group first. Remember, in permutation, 3 groups can be selected in 3 factorial ways. 3 groups can be selected in 3 factorial ways. So, number of ways of dividing 12 students in 3 groups will be given by 3, 4, 650 upon 3 factorial. Okay, so how much is this? 3 factorial is 6 divided by 6. Answer is 5777. Okay. Let me explain again. I have students, 12 students. I need to put them in 3 groups. Group number 1, group number 2, group number 3. How do I do that? I will do that by putting them in first 12 students. Out of the first 12 students, I take 4 students. I put in them in first group. Then I take the remaining 8 students. From them, I select 4 students. I put them in group 2. Remaining 4 students are there. I put them in group 3. But I don't know whether I started with group 1, group 2, or group 3. So this 34650, I must divide it by 3 factorial to be able to come to the number of ways in which I can distribute 12 students to 3 groups. Okay. So I'm taking all the difficult sums so that all the easy sums you can do on your own, but the difficult sum, whenever you are stuck in the problem, you can refer to the video. Please revisit the video so that you will be able to understand better. Okay. Let me see. Is 4 factorial into 0 factorial is 4 factorial. 0 factorial is how much? 1. So 4 factorial is 24 into 1. So 24. Okay, Harnoor? Yes, you can, Harnoor, you can do that also. No problem. Yes, Harshita, understood. Very good. Yes, Vagdevi, that question I don't have place to write, so I will take it in the last. Okay, don't worry, I will take it. Now, now this question, 16th and 17th, remember that in 16th question, you had students, right? So students you can identify. Okay, if I put a student, so you have remember in school you have division A, B, C. You can recognize the division separately, isn't it? Why? Because you know this. Suppose Harnoor is in one division, Vagdevi is in another division. So you can recognize those divisions. But in the 17th sum, we are dealing with mangoes. Can you recognize one mango from the another? No, you can't do that. Okay. In this, remember that students I could recognize, but in the next question, 17th question, I'm not able to recognize the mangoes separately. So when I'm dividing the mangoes amongst 3 students, I don't know that this set of mangoes is different or this set is different. They look all alike. Okay. So here, when I want to distribute 15 mangoes among 3 students, 15 mangoes amongst 3 students. So each student gets 5 mangoes. Each student gets 5 mangoes, right? So I will see that this gives me what? 15C5 into, I have finished with 5 mangoes. How many mangoes remain? 10. 10C5 into 5C5. How much is 15C5? 15 factorial upon 5 factorial into 10 factorial into 10 factorial upon 5 factorial into 5 factorial into 5 factorial upon 5 factorial into 0 factorial. Now, this 10 factorial cancels with this 10 factorial. This 5 factorial cancels with this 5 factorial. And I get this as 15 factorial upon 5 factorial. Okay. So 17th answer is B. Okay. So here can you find out that here we have not divided by 3 factorial, because if I have 3 baskets of mangoes, I will not be able to recognize one mango basket from the other. So here we don't do that. But in the earlier sum, we have divided by 3 factorial. Okay. Yes, Bihu. Thank you. Yes, Zeba, right. Latif, yes. I will explain again. Don't worry. See what happened, Latif, here. Let me just write it. I had 15 mangoes. Okay. Student 1, student 2, student 3. Okay, I took the 15 mangoes, gave 5 mangoes here. How many remained? 10 mangoes. Out of these 10 mangoes, I gave 5 to S2. And remaining 5, I gave to S3. Okay. This is the way I have to distribute. Now, when I want to, out of this 15, I want to give the first student 5 mangoes, I can do that with 15C5. Okay. 15C5. Then how many will remain? 10. So out of the 10, I will give 10C5 here. What will happen over here? I have only 5 mangoes and I have to give all of them to that student. So this is 5C5. So 15C5 into 10C5 into 5C5 is equal to this much. So I hope you've understood here. Right, Latif? Yes. Let us take the next sum. Every 2 persons shake hands with each other in a party, and the total number of handshakes is 66. The number of guests in a party is. Yes, Aska. Thank you so much, Isha. Yes, Latif. Thank you. Now see, for a handshake, how many people do you require? For a handshake, we require 2 people. Okay. We require 2 people. Okay. So just remember that. So I have NC2, 2 people. And I don't know number of people in the party. So I've just gone into a party. There are so many people standing there, and I go and shake hands. I to know, and I just remember how many people have shake hand with, so I don't remember that. So I know that I have shake hand 66 times. So NC2 is 66. So what do I have is n factorial upon 2 factorial into n minus 2 factorial is equal to 66. So I have, now I will take n factorial up to n minus 2. So n into n minus 1 into n minus 2 factorial upon n minus 2 factorial is equal to 66 into 2. This n factorial, this n minus 2 factorial and this n minus 2 factorial will get cancelled. So I have n into n minus 1 is equal to 132. 66 into 2 is 132. Now I must find two numbers which are consecutive and whose multiplication I will get as 132. Okay. Now from here, this is a hint that I want to give you. From here, I can make out 11 is prime. Okay. This number can be divided, 66 can be divided by 11. So this will be equal to 11 into 12. Okay. But you don't have to worry. Options are given. You just have to put the option and multiply and see. Number and number minus 1 should come to 132. Suppose they give me an option A to be equal to 10. Now let us see. 10 into 1 less than n into n minus 1. 10 into 9. This is 90. Right? Which is not equal to 130. Okay. So I will have option will be given to me as 12. Okay. Here n is equal to 12 because 12 into 12 minus 1 is giving me 132. So 12 and 12 into 11 is 132. So what is the value of n? N is 12. So answer here will be 12. Okay. Okay, 8 points are marked on the circumference of a circle. The number of chords obtained by joining these in pairs is given by. So I have a circle. I have points 1, 2, 3, 4, 5, 6, 7, and 8. So I have this 8 points. So 8 points are marked on the circumference. What is the circumference? The round ring is known as the circumference of the circle. The number of chords obtained by joining them. So what is a chord? I will show you. This point on the circumference, when I join with this point, this line is called as chord. This is called as circumference. And this is called as chord. Okay. So 8 points are marked on the circumference. The number of chords obtained by joining these points is. So I want to find number of chords. So what they're asking me to do is, it wants me to find out, like how much can I do this? I can join this. Then I can join this. So how many lines are there? Okay, they want me to find out how many chords are there. So number of chords is equal to 8C2. Because for one chord, how many points you are required? 2 points. So this is equal to 8 factorial upon 2 factorial into 6 factorial, which is equal to 8 into 7 upon 4 upon 2, which is equal to 28. So C will be the correct answer. Okay, understood? Yes. Let us go to the next sum. Yes, this 10 sum is, they have already given us the formula. The number of diagonals in the decagon. They have given the number of diagonals in a polygon of n sides is. So, number of diagonals is equal to 1/2 n into n minus 3. What is a decagon? Decagon is with 10 sides. Okay. It is with 10 sides. So how much is n? N is equal to 10. So number of diagonals will be equal to 1/2 into 10 minus 3, which is equal to 7. So 70 upon 2, this is equal to 35. Okay. Yes. So this is 35 will be the answer. Right. There are 12 points in a plane of which 5 are collinear. The number of triangles is. Now what is collinear? Collinear means they are lying on the single line. Okay. So suppose I have this line. Then point 1, point 2, point 3, point 4, and point 5. These 5 are lying on the line. Okay, so they are collinear. So what happens is, out of the 12 points, suppose none of them were collinear, then the number of points required to make a triangle is how many? 3 points, right? So if no points were collinear, we would have got number of triangles is equal to 12C3. Because I know for one triangle I need 3 points. Total number of points are how much? 12. So 12C5. But less. Because I have 5 points which are collinear. Less triangles cannot be formed with collinear points. I'm giving this in writing because you have this is for your understanding. In the exam, you don't have to, you just have to subtract. Is how much? How many collinear points do you have? 5. 5C3. So 12C3 minus 5C3 will give me the answer. How much? Let me see. How much is 12C3? 12 factorial upon 9 factorial into 3 factorial. This is equal to 5C3 is equal to 5 factorial upon 3 factorial into 2 factorial. So let me show it over here. 12 factorial upon 9 factorial is 12 into 11 into 10 upon 3 factorial is 6 minus 5 into 4 upon 2. So 2 ones are 2 twos are. 6 ones are 6 threes are. 6 twos are. So 12. I'm dividing 12 by 6. 6 ones are and 6 twos are. So how much is 2 into 11 into 10? 2 into 11 into 10 is 220. Minus 2 into 5. That is 10 triangles are there which will be formed from the collinear triangle. So this is 210. So if I have 12 points of which 5 points are lying on a plane, then the number of triangles that can be formed is, first I will take the condition that there is no condition. So no condition scenario, 12C3. Out of them, I will remove the triangles which cannot be found when 5 points are collinear. So how many points, how many triangles are there? 10. So 220 minus 10. So you will get 210 as the correct answer. See, now this question, 12th question is same like the earlier one, but now they are saying there are no collinear points. So number of straight lines, they are not, there they talked about triangle, here they are talking about straight line. Number of straight lines obtained by joining 16 points on a plane, no 3 of them being on the same line is, okay, so this is 16C2. Why 2? Because for a straight line, when I want to draw a straight line, these are my 2 points. So for a straight line, I need point number 1 and point number 2. So therefore, I have taken 2. Where did the 16 come from? They have already given 16 points on a plane. So this is equal to 16 factorial upon 14 factorial into 2 factorial, which is equal to 16 into 15, because 14 factorial will get cancelled upon 2. So 2 ones are 2 8s are. So you have 18, 15 8s are 120. So A will be the correct answer. Let's just check. Yes, A is the correct answer. Okay. Okay, so we've already run out of time. Yes. I will take that sum that has remaining on the revision test. Okay. Yes, Nital, very good. Okay, Aska, this you want? No, see here, this is 132. Now I must have 2 numbers, one after the other, whose multiplication I should get 132. But see, 66 is what? 66 is 11 into 6. So 11 is a prime number, I already know. So I will write this as 11 into 6 into 2. For 66, I have written as 11 into 6 into 2. This is equal to 11 into 6 into 2 is how much? 12. So 12 and 11, are they consecutive? Yes. So what I wanted was consecutive numbers. Now which is the bigger number? 12 is the bigger number because n into n minus 1. Had it been n into n plus 1, then I would have seen it differently. Here it is n into n minus 1. So 12 is equal to n. Clear, Aska? Thank you, Zeba. Thank you so much. Yes, Nital. Okay. Okay, there are 2 only sums remaining, so don't worry, we will take them up later on. Okay, I will request, or you can also request for an extra lecture and then we can have them also. Okay, don't worry. So thank you for your patient hearing. Have a great day ahead and study hard, and then we will meet on in the next lecture. Thank you so much.